in your practices, I don't know if you will ever meet something like this, but if you see in other examples references to memory and storage, then at least you have some idea what's going on. And otherwise you can just Google it and find more info. The error handling, I just before showed that you have the require, which is over here, which tests for a value, and if it's a condition and if it's not right, it shows an error message. And actually there are 3 variations of those checks. You have the simple revert, and that's just when you end up in a situation where you say, well, it's not, something is completely wrong, we have to stop. And then you call this function revert with an error message. And you can see the error message in Remix, for example. And what it does is actually all the changes that you've done before in your function, they're just discarded. So it's just not stored on the blockchain. So you're back to where you started. And actually, require is also like that. Assert is also testing things and also shows an error message if it doesn't work out. But the difference is you're supposed to use this one for to checking the input parameters of your function. So that's usually what you do at the beginning of your contract. And assert is used to test invariance in your contract. And in case, do you all know what invariants are? You learned that in programming classes? No? Invariants are if you want to verify the correctness of your program or prove that your program is correct. And you can create statements to see that everything is okay. For example, that a variable is always bigger than 0, or it's always smaller than 100, or that, for example, variable a plus b are always 100 or something. So if you think about it, then you can create some rules which are always true. And you can use that in a sort of mathematical construction to prove your program is correct. And the idea is that you can you put assertions in here to verify that nothing has gone wrong. So that it's a number that should be bigger than 0, that is always bigger than 0. Or for example here, if you add y to e, then it should e should always be bigger than y. It's not possible to have it another way. So this should never ever throw an error. And to test it, I've put here the exact opposite. So this one throws an error, but that should never happen. So you can play with this to figure out the situations. Okay, this is also a more advanced situation. That's just to let you know that it's possible. And what this is doing, that in one smart contract, we're going to create another smart contract. And that can be useful in some situations. And often that's called a factory, so a factory of smart contracts. So this is the child contract that we want to create. So we have in one piece of source code we have 2 contracts. You see, over here. Here it says new child contract. So that creates the new copy of this, and it gives, in this case, a parameter of child number, which is a variable which is over here, which starts at 0, which is compared to other programming languages, normally you would have to initialize your variables, but in Solidity everything starts at 0. So it's okay to do it like this. And then I said plus plus before, so it first increases it to 1. So the first child contract gets number 1. It goes into this constructor, it stores this in this variable, so it remembers which child contract it is. And I'll show it in Remix what it looks like. You see a different feature of Remix, because now we have 2 contracts. If you would do this in the Play editor, it doesn't work because it only supports 1 contract. But in Remix you can have multiple contracts. And in this drop down here, you can choose which one you want to use. So in this case, I'll take the contract factory and I deploy it. And I have some functions here like who am I, just to see where what I am, and my address. And now I'm going to create a new contract. So it has created it here. Let's see. So here we have the new contract with this address. And what I can do now here is go to the child contract. And I could deploy it, but that's not what I want now because it has just been deployed by the factory. So what I can also do is here load the contract from an address where it's already deployed. So I paste the address over here. And then I say, click this button, and then you get something like that. And then I can call the function, and okay. Done something wrong because now I have the factory again. Let's see if I yeah. Do you see what I've done wrong? It's always easier to blame you than myself. I copied this one, this address, but that's the to address from the factory, so that's actually the factory itself, and I should have copied this address. And then try it again. Yeah, now I have the child contract with ID number 1. And if I would call the factory again, and it will create a new one. And if I copy that again, put that in here. There's a new one. Which is also a child. And it has number 2. So now we can create as many contracts as we want. Is it clear? Okay, now I have a few sort of complete contracts. One is the casino one, which I saw some already use that to extend that to create their example contract on that. And probably most of you have already seen it. I'll just try to explain it a little bit. Most you should be able to understand. Here is a function to get the balance of the smart contract. So what the contract does, it's a betting contract. You put in some money and you bet on it to be red or black or 0 or 1, odd or even. And if you win, then you get double your money back, and if you lose, then the money stays at the smart contract. So with this function you can see how much money there is in the smart contract. Well, first we start with the constructor, because the smart contract, which is sort of the bank of the casino, has to have some money, otherwise betting is not much fun. So if you forget to give any money to the contract, then it doesn't really work. You always get an error message. So you provide some money to it. You don't have to say anything, just that it's payable, and then you get the money into the contract. Okay, then you call the function bet and win, and you also supply the amount of money that you want, or the ETH that you want to bet. If you don't supply anything, it's also not so much fun. So it tests here. Oh, no, I'll just go from the top. It's first message of the function, and then address of that. It calculates or determines the bet. That's just the amount of money that you send to the contract, and then it has to calculate the payout. And the payout is actually double the bet. Initially, I had the payout is bad. Because I thought, well, you want to pay out as much as you have betted, but that's not really true, because with the bet you already give the money to the smart contract, so you don't have the money anymore. So you either leave all your money at the smart contract, or you get double your money back again. So that's why the payout needs to be twice that amount. Now then we check out how much money the bank has, and then we're doing some checks. First we want the bet at least to be larger than 0, otherwise not much fun to bet. Then you get an error message. And of course the payout should be less than the balance, otherwise the bank cannot pay out, and then that's also not so much fun. So once you're through to that, then you can start doing some betting. Then you need a random number, and for the random number I've created this small function. And what it does, it takes some information of the block, and it's the difficulty. And difficulty that's related to the mining. When you do the mining, then you have to calculate a number which has to start with a number of zeros. And the difficulty for that, that's this one. And the Coinbase, that's the address, Ethereum address of the miner. So that depends on the miner. And the timestamp, that's the time when the block is created. So all of this is not really super random because it can be manipulated by a miner. But for example, it's sort of okay. Then I'm calling a function AB encode fact. What it just does is it combines the values that is given and combines that into a data structure. So it doesn't really matter what it does, it just puts this in, and you can also extract those values if you want. It makes a sort of struct out of it. Then we're calling a hash function over that to make it more difficult to understand. And the hash function, we are turning that into a number. And that number we are returning, of course.
How do you, with the unsigned integer of 265,
yeah.
How do you make that hash with letters and stuff and into a number? What happens then? What does it do?
Yeah, the hash is actually a hexadecimal number, so that's already a number.
Oh, it's already a number.
Yeah, it's
you
already
just
a
make
number.
it an integer.
Yeah, yeah.
Right.
Yeah.
Okay.
But otherwise you get the type error, but it's 0x blah 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 and lots of numbers.
Okay, so it understands that x isn't a number.
Yeah, it understands that 0x means hexadecimal. But actually you only see the 0x in if you do something with JavaScript or something. At the low level, at the assembly level, there's no 0x. Yeah, the number that comes out of here, is easy to translate to here. So then here you get a pretty large number, I think 32 bytes. And then it over here does the modulo of 2, so that means it only takes the last bit out of it, and it checks if it's odd or even. So that's 0, 1, so it's either 0 or 1. We convert that to a boolean. So the 0 is always false and the 1 is true. And that indicates whether you win or not. So if you win, so if this value is true, and that means if this value is 1, and that means that the number was odd, then you win. Then we transfer the payout to the bet placer. So that's the message sender, and he gets his money double back. And then we also do an emit, so log whether you have won or not. Try to show that also on the remix. I've also made a small movie about that, and here you can also see it all on Remix, what I'm doing to simulate or run this game. Okay, now I'm ready to deploy it. Now I have to give some money to the contract, to the bank. Deploy. Have a check the balance. Yeah, it's the amount that I've just entered, so it has some money. Now I'm going to try out, first try it out the random, see what happens. Yeah, here you see the large number. So you see different random numbers. Okay, if I now press bet and win, what do you think will happen?
You haven't bet anything, right? But
So-
there's a place to bet.
Yeah.
An error or something.
Yeah, so I also expect an error. Yeah. It is an error. No money added to the bet. Okay, so I'm going to fool the contract. I want to bet for 1 ether. What will happen?
Error.
Error.
Money in the bank.
Not enough money in the bank. Yeah. Okay, a small amount should be plenty. No errors. Then see at the logs if I have won or not. And I didn't win, so that's a pity. So I try again. I didn't win again. Yeah, now I've won. So the bank balance, yeah, of course the bank has won because I've did 3 bets and I lost 2 of them. And won 1, so the bank has an advantage, so the bank has won. But there are contracts like this on Ethereum, not exactly like this, but more or less like this. And a couple of months ago, it was even the Ethereum chain was slowing down because on a contract seminar like this, people were betting enormous amounts of money, and the entire blockchain was being slowed down. And in that contract were a couple of $1 million worth of Ether. So if you want to be
Isn't that
rich,
illegal or something? Aren't there rules for?
yeah, in Holland it's kind of illegal, but yeah, who knows if you're in Holland. So it's difficult to figure out who is doing that.
Yeah.
So if you want to be rich quick, well, maybe you shouldn't use this contract exactly, but maybe you should change the payout a little bit, because now it's a little bit too fair. Now it's 50-50, but if you say, well, 10% always goes to the bank, then you can get rich pretty quick. But it could be illegal. Here's another smart contract which uses a lot of the concepts that I've showed before. So you should be able to recognize everything, I think. See if there's anything new in it. Now this is maybe a construction that's found in some languages, but not in all. In C, for example, has something like this. Do you know what this means?
Ternary operator.
Sorry?
Ternary operator.
And what does it mean?
Well, it's a shorthand syntax for if and else.
Yeah. Can we understand?
Ja, so ik heb wel eens doe
Ja.
now, otherwise you
Yeah.
called Elvis operator.
Yeah, that's fine. If this, then that comes that. So it's quite useful, but if you have never seen it, then it's a bit confusing. Here's another example. I think that's even the one for, which is standard in Remix. One special thing here is the experimental pragma. Sometimes you see some experimental things over here, and this one is to allow to structs to be passed through functions. Not sure where they do that. But if you see something like that, you have to be very careful with experimental things. It's nice to do experimental things during classes and to test it out. But if you want to go into production, you would normally never have anything experimental with it because it's just too high risk to do that. I don't think here is anything new. Okay, then it's about time to start practicing again. So this is what I would like you to do. Just go and play with the Remix environment so that you get familiar with it and know how it works. You can check out some demos. There are small movies that I've made on how you can use Remix. But I've also showed it quite a lot now, so it probably shouldn't be really necessary. In this directory, the examples that I just showed are also there, so if anything is confusing, just try out a couple of those. And especially try out the debugger of Remix. It gets it takes a little bit time to get used to, but it's very useful if you cannot figure out what's going on with your contract. So that's the idea, and then either continue to work on the smart contract that you already made, or make a new one if you don't like it, and then at least put a few of the functions in that we explained today. So at least something with the error handling, something with mapping, and something with events. And then at the end of the day, or at least before our next class, put it on GitHub again.